Okay, guys, this is part two. We're going to be looking at formulas. The formulas can be used to determine what the next term of a sequence would be or what the 95th term of a sequence would be. And so instead of having to figure out what every single number is in between, we can just use formulas to do that. So the explicit formula tells us what the nth term would be. The recursive formula tells us what the next term would be. Okay, so you're going to be using both of those in your homework. And if you'll notice, I kind of tended more to use more of the explicit formula versus the recursive formula, but because the explicit can tell you any number that you're looking for, any term, where the recursive can only tell you the next one. So we're going to skip the problems, and this is exactly what's on your notes that I made for you. So refer to that as often as possible so maybe you can memorize these formulas. So identify each sequence as arithmetic, geometric, or neither. If possible, determine the 50th term of each sequence. Now, it's only going to be possible to do that if we have either an arithmetic or a geometric sequence. So the first thing that we need to do is look at this and say, do we have a common difference or do we have a common ratio? So go ahead and figure out if we have the common difference or if we have a common ratio. So that's step one. Okay, so we can see here that we have a common difference because -1 minus -5 is equal to 4, and 3 minus -1 is equal to 4, and 7 minus 3 is equal to 4. And if we chose any two consecutive numbers here, we would see that it's equal to 4. 23 minus 19, 4. 19 minus 15, 4. 15 minus 11, 4. 11 minus 7, 4. So right now we know this is an arithmetic sequence. So what is our 50th term? Well, for this we need to go back and look at what the formula is on the previous page, and we're looking for arithmetic. So I'm going to pause it and write down what this formula is. Okay, so for an explicit formula for an arithmetic sequence, it's a sub n, so a to whatever power you're looking for, is equivalent to the first term of the sequence, a sub 1, plus the difference times the term minus 1. So in order to fill this in here, we're going to say a to the 50th is equal to, not a to the 50th, I'm sorry, the 50th term, a sub 50, is equal to a sub 1, which is your first term, -5, plus the difference is 4 times the 50th term minus 1. So we've got -5 plus 4 times 49, which is equivalent to, which is equivalent to 191. So -5 plus 4 times 49 is equivalent to 191. So our 50th term would be 191. Now, looking at part B, what type of sequence do we have here? Well, we can see right away that we do not have a common difference because 1 minus 0 is 1, and 1 minus 1 is 0, and 2 minus 1 is 1. So we don't have a common difference, so we know right away it's not arithmetic. Now, what about geometric? Well, 1 divided by 0 is undefined, and 1 divided by 1 is 1, and 2 divided by 1 is 2. So this is neither geometric nor arithmetic. So we can't do anything else. In our 50th term, we cannot figure that out. So we're not even going to go there and try that. So what about the next one? What type of sequence is this? So spend a minute, do it, and then come back and check your answer. So go ahead and pause now. I hope you determined that they have a common ratio here of 1/3. So our type of sequence would be geometric because we have a common ratio of 1/3 between each of these terms. Now, what is the 50th term? Again, you need to write down what your formula is your explicit formula for a geometric sequence. Okay, so since this is a geometric sequence, we're going to be using the formula g sub n is equal to g sub 1, our first term, times our ratio raised to the nth power minus 1. So here we're looking for the 50th term, so we have g sub 50 is equal to g sub 1, our first term is 27, times our ratio is 1/3, and we're raising that to the 49th power. Now, our answer, when you say 27 times 1/3, and make sure that's inside parentheses, raised to the 49th power, is 1.12 times 10 to the negative 22nd power. It is so important that you include that times 10 to the negative 22nd, because if you don't, your answer is very, very wrong. Guys, this means that you have 21 zeros before that 1. So you have a decimal point and 21 zeros, and then 1, 1, 2. So it's very, very, very close to 0. Okay, so looking at problem 5, you are going to have a few word problems. The sum of the interior angles in a triangle is 180 degrees, in a quadrilateral 360, and in a pentagon 540. How many degrees are in a decagon? This takes you back to a little bit of geometry. A decagon means it has 10 sides. 10 sides. Triangle, 3 sides. A quadrilateral, 4 sides. A pentagon, 5 sides. So, what is happening between these? Well, between a triangle and a quadrilateral, we would say it's 360 minus 180, which is 180. Positive 180, sorry. And then we've got a pentagon, 540 minus 360. Again, that's 180. So we can see that every time we add a side, that we also, our interior angles come up to 180 degrees more. So what about a decagon? How many sides, or how many angles would, what would be the total sum? I'm sorry, how many degrees are in a decagon? There we go. Okay, so in a 3-sided figure, we have 180, and a 4-sided 360 degrees, and a 5-sided 540 degrees. How many degrees are in a 10-sided figure? We already determined that we have a common difference, and our common difference is 180 degrees. So we know this is an arithmetic sequence. And so if you use that formula, you've got our first term is 180 degrees, plus our difference is 180 times the difference between 10 sides and 3 sides. So you've got to think about that for a minute, because our first term had three sides. So we're talking about really what our 7th or 8th term would be. So we've got n minus 1, we're talking about a difference of 7, and then if you say 180 plus 180 times 7, you get 1,440 degrees. Okay, that might have been a little confusing, and I apologize. But make a little table to the side. We know 3 sides, you've got 180, 4, 360, 5, 540, and then 6, 7, 8, 9, 10. And so this is our first term. So down here would be our 2nd, 3rd, 4th, 5th, 6th, 7th, 8th term. And so the difference between 8 and 1 is 7. And that's where this 7 right here comes from. Okay, class is about to begin. So I'm going to go ahead and end this video. And if you have any questions, please ask me in class tomorrow. Thanks.